Alright, so today we're going to be talking about the unit circle and basically all its functions and stuff, so we'll just get straight into it. So here we have a normal XY coordinate graph, and basically what the unit circle is just a circle at the center of the X and Y coordinate, and it has a radius of 1 unit. The unit circle is primarily used to extrapolate trigonometric functions. For example, once getting used to the concept of the circle, mathematical problems such as sine of 30 or the cosine of pi over 2 will be easy to identify, and you'll be able to just get it easily done. So let's talk about what the 30 and the pi over 2 means for a quick review. So the 30 that I repeated in like sine of 30 represents a degree, which is a unit of measurement used for a circle, which has either 1 through 360 degrees. And the pi over 2 represents a radian, and a radian measures angles by distance traveled. So, for example, each circle will have a circumference of 2 pi times the diameter. Regardless of what d is, or what the diameter is, 2 pi represents the measure of the whole circle. So then, this would mean that pi would be half of the circle, and that pi over 2 would be a quarter of a circle. Alright, so first off, you guys should probably know about the types of special triangles there are. So the two most common ones are the 30-60-90 triangle and the 45-45-90 triangle. So just for a quick review, the 30-60-90 triangle has a measure of, let's say, x for the side that is opposite to the angle of 30 degrees, and the measure of the side which is opposite of the 60-degree angle is x root 3, and the side that is opposite of the measure of the 90-degree angle is 2x. And then for the 45-45-90 triangle, it's just the two sides, two equal sides that are not the hypotenuse is the, well, x measure, we can say, and then the hypotenuse would be x times root 2. So just for like simplicity purposes, just to get the concept known, we're just going to be using these known angles that will make it easier for you to figure out the types of values. So we're just going to use like 30, 60, 90, and 45. So just for a quick reference, we're going to go over how you can convert degrees into radians. So to convert the value of a degree into a radian, you would have to multiply the given degree value with pi over 180. So for example, if you have a degree of 180, you would multiply that by pi over 180. So then obviously that would get you pi in radians. So using this same method for like 30, 60, or 90 degrees, 30 degrees would be pi over 6, 60 degrees would be pi over 3, 90 degrees would be pi over 2, and 45 degrees would be pi over 4.
Now that we have a basic understanding of what the unit circle is, we can go more in depth about how to actually use it. So on this unit circle, we can create an angle by drawing a base side right here and another side that crosses the unit circle at this point right here, and we can call it A, comma, B. So now that we have this angle right here, so we'll make this theta, we could turn this into a right triangle to solve it. Drop a line down and make it a 90-degree angle. So now that we have this right triangle, we can find the hypotenuse easily because we know that it's in the unit circle, and the unit circle has a radius of 1. So the hypotenuse has a length of 1. Now, in order to declare what this side is, we know that this point right here hits this point right here, and we can say that y equals b, so the height of this side right here is b. And we can do the same for this side right here, so when we drop right down, we can see that x equals a, so we can say that this side is equal to a. Now, whenever we're trying to solve for a right triangle, you can always go back to SOHCAHTOA. SOHCAHTOA. So just a refresher, SOHCAHTOA is your sine. In order to find sine, you have opposite over hypotenuse. In order to find cosine, you have your adjacent over hypotenuse. And to find tangent, it's the opposite over adjacent. So if we want to find the length of A, we can just say cosine of theta is equal to the adjacent, which is A, over the hypotenuse, 1. And if you want to find B, which is opposite to angle theta, we can use sine. So that's sine theta equals the opposite, which is B, over the hypotenuse, 1. So now that we have this, right, we can say that cosine is equal to A and sine is equal to B. And because of this, we can change this coordinate right here into cosine, comma, sine. And through this, we are able to find out the radians or the degree of the angle.
About the unit circle, there are specific problems that we could solve using it. So, for example, we have sine of 30, and we wanna solve this using a unit circle. One way that we can do this is using the 30, 60, 90, and the 45, 90 triangle. So say we draw out a triangle like that with a right angle and this angle being 30. Let me make it bigger. So we have a triangle, 90 degrees over there. We have 30 degrees over here, and we have 60 degrees over here. Here we just memorize that this side is 1 because of the unit circle, this side is 2, and this side is square root of 3. Using what we know for SOHCAHTOA, where SOHCAHTOA, we know that sine of an angle, so sine of theta, for example, is equal to opposite over hypotenuse. So it equals opposite because of SOHCAHTOA O and H, so opposite over hypotenuse. Right, so sine of 30, for example, so sine of 30 equals opposite, which is 1, over hypotenuse, which is 2. So sine of 30 equals half. Now, another example is, say you have cosine of 30. Cosine 30. What would this equal? What does this equal? So, looking at the SOHCAHTOA again, cosine of an angle equals adjacent over hypotenuse. So cosine of 30 equals adjacent, which is square root of 3, over hypotenuse, which is 2. And that's the answer. We need to know is the 45, 45, 90 triangle. Right, so say we want to find sine of 45. Now, we can't do this with the normal 30, 60, 90 triangle, but we can do it with the 90, 45, 45. So say we draw a triangle, and instead this angle is 45 degrees. This angle is 45, and this angle is also 45. Here, again, using SOHCAHTOA, we could do the same thing. So sine would equal, sine theta, which we know equals opposite over hypotenuse. So we know that sine 45 equals opposite, right? So in this case, what is opposite equal? Opposite is 1. So for these triangles, 1, 1, and square root 2. So these values you just need to memorize. You memorize this for the 45, 45, 90, and for the 30, 60, 90. So opposite over hypotenuse, so sine of 45 is 1 over hypotenuse, which is square root 2, and that's our answer for sine of 45. We want to do cosine of 45 for another example. Cosine of 45 is adjacent over hypotenuse. So adjacent over hypotenuse. So cosine of 45, what does that equal? Well, adjacent is 1 over hypotenuse, square root 2. So these are equal to each other. If we need to know the reference angle. So the reference angle for anything in quadrant 1 is just its own reference angle. So that's that. The reference angle for anything in quadrant 2 is 180 minus the angle. So minus that angle, we have 180 minus quadrant 2 angle. If for quadrant 3, the reference angle is the quadrant 3 angle minus 180. And for for quadrant 4, the reference angle is 360 minus a quadrant 4 angle. So, for example, if we have sine 120 and we want to solve this, sine 120, here we can draw a small picture to help illustrate this. So we have the quadrant plane, so there, and we want to draw a triangle. So we go up and down, right? Because this is 120 degrees, 120 degrees, right? Now here we know that the reference angle for quadrant 2 is 180 minus the angle. So 180 minus 120, 180 minus 120 is 60. We know that this angle is 60, and our reference angle is this angle. So that's 60, and that's 30, right? 30, 60, 90. And across from the 60 is going to be square root 3. This is just memorization. Across from the hypotenuse is going to be 2, and this angle is going to be, and this in the side is going to be 1. If we want to find sine of 120, we know that sine is opposite over hypotenuse. So opposite is square root 3, and hypotenuse is 2, so square root 3 over 2. However, since this is in quadrant 2, all x values are negative, right? And x is so it's going to be minus 1. That's negative. Update this value, minus 1. Sine 120 is just equal to root 3 over